Find an inverse again. This time you have a logarithm and a number added to logarithm of x minus 8. So how do you find inverse? Again, why don't you give it a shot? Let's see what answers you get. How many different answers you get this time?
Can we repeat the regular spine?
Yes, sir. We shall do as you promised.
You're not the boss, babe. All in one right there.
We're on record. So that's the first one. Okay. Any ideas where to start? I know you have an idea here. Tell me. Yes.
Divide by e to the x.
Yeah, I see e to the x on both sides. I mean, solve means leave x alone, get rid of all the junk here, and this is a great idea. E to the x, divide both sides by it. I have one on each side. Don't write. And we get x squared equals, so these cancel, so you have x squared. What do you have on the right side? These cancel? Is it 1? Yes. Oh, square of a number is 1. What is that number? We just need to take square root of both sides, right? And we get plus minus, of course. Answer is
Plus or minus 1.
plus and minus 1. Okay, let's try that. That's 13 minus 1 plus 1. You were right. Okay. That was the easy way, but dangerous way. Why? What if I change this question into this? Okay, how would you do this question? This is plus minus 1, we got it right. Perfect. How about now? Why don't you do the same thing, right? Can we do the same thing? Can I cancel them? Can we cancel them? Alright, I'm canceling these as well. And I think we get the same answer. How great is that? Take square root of both sides. Any objection?
1 minus 1 minus. Which would be 0.
This will be 0? Why?
Because 1 divided by 1 is 1, and e to the x divided by e to the x is also 1.
Oh, no, you're trying to separating this like that? No, we can't separate them like this. They won't split up because you're saying this 2 minus 2 and 2 minus 2. According to your idea, you can separate 2, 2, 2, 2 like this, and it's 1 minus 1, it's 0. But this is actually 0 over 0, undefined. Okay? So we cannot separate this. Here's how you can separate. If you really want to separate, you need to take this entire denominator with 1. This is okay. And then you need to take this entire denominator with this guy. This is how you can separate, okay? This is okay, but not the other way. And I can't cancel nothing here. These two won't cancel because there is something subtracted. So this is correct. What I did is correct. What I'm trying to prove you here is, this is okay. You got the right answer here. But you may not be that lucky all the time. Why? Because the solution is not only a plus minus 1 here. There is a third solution you missed. Why did you miss that? Because you canceled a variable from both sides. And what is that term you missed? There is one more solution. X equals 0 is also solution here. Look, substitute 0 here in the original equation. Clean this up. Clean this up and this up. Make it back to original. I broke it again. That's just the battery, I hope. They should make it out of steel or something for me. Yeah, it's still working. Alright. So, this was 1 minus x, right? Look, try zeros now, both parts. What is e to the 0? E to the 0 is, a base not raised to 0 always 1. And 1 minus 1 is this side 0. Oh, by the way, I forgot to put 0 here too. Anyhow, this is also 0. That's 0. Look, 0 satisfies this. And you missed this valuable solution. So division is dangerous. You risk losing one of the solutions and you get only partial solution. Why don't we lose that solution here? Because this thing, e to the x, can never be 0. It's always more than 0. You are safe to divide both sides. If the stuff you're dividing both sides can possibly be 0, then you are losing the solution, possible solution. So this is okay. You can divide both sides because they match and they are definitely more than 0. E to the x is always a rising graph. So what is the right way to solve this though? Don't divide, please. And again, if you're dividing, make sure that part you're dividing is never 0 and you're good here. The right way to do these questions is always bring stuff to the left side. Subtract this, take it to the left side, okay? And we will have on the left x squared e to the x minus e to the x equals 0, because these two cancel. I subtracted. And then, as you notice, these two are common, so I'm going to factor them. Factor the first one, factor the second one. I'm factoring these right here. Okay? And we will get only x squared minus 1. And set each into 0. Now, each piece. Look, there is a possible solution here. I said it's possible, not guaranteed. And there are two solutions on this side. And you put this to this side, you get x equal plus minus 1. These are actual solutions, but is there any solution here? You raise e to the power of x and it becomes 0. You can test this by putting ln to both sides. Bring x ground. Ln e cancels each other to 1. What is the value of ln 0? Can you compute ln at 0? No, this is undefined. That's because e to the x can never be 0. That's why you were allowed to divide both sides, because they never became 0. However, here, you're not allowed to do that. 1 minus e to the x can be 0. Okay? So no solution here, two solutions there, and we tested that it's correct. Okay? So I'm not 100% opposed to dividing both sides by variable. Do it if you are 100% sure the divided piece is non-zero all the time. For example, in this question, you can divide both sides by x squared plus 1 if you wish, because x squared plus 1 is always positive. It's never becoming 0. I don't know how you're gonna proceed this, but you can divide this thing. So if you're sure it's not 0, divide it. Otherwise, don't. Factor all the time. So, if you notice division, it works. It's 10 seconds question. Otherwise, you need to do this. But it's still getting the same answer. All right. Number 14. And as you see, all these questions are a little bit challenging. Because we did the moderate or easy type questions in the sections. Now this review set is a little bit challenging questions, and this is one of them. We need to solve x. But it's in double prison. It's in double prison. First they have put x in this prison, and they took the whole prison, put it inside another prison. So you need to, whatever you need to do it twice. That's the story I got. Lesson we learn here is 2 logs require 2 weapons. What do you do? What would you do? What was the right weapon to wipe out logarithm base 10 before? How did I do that question? Yeah. I had a princess locked in base 10 prison. How did I take care of that base 10 prison?
Set it to a base.
We raise it to a base, right? Base of 10. What base do you see here?
4.
So that's what I'm gonna do. I will raise both sides to the power of 4. And put this guy to this top. Yeah, I needed more space. Okay, is that okay? Now what is next? Something is canceled.
The left side cancels with the first log 4.
Yep. Do you see the match? Bases match. Log and exponential, they are inverse of each other. They cancel. They cancel away. What happens to this prisoner? It was locked in this outside prison. What happens to it? It falls down. Okay, what is next?
Do it again.
Yeah. Your princess here, locked in this prison, and that prison is blown away by if you put 4 on either side and put those equations to the top of them. Okay? Cancel, cancel. X is 4 to the 4th. What is it?
56.
Very good. Questions? Okay. All right, and the last question of the day, not the day, this section. Still have time. You're buying a new SUV for $25,000. Well, when you leave the dealership, it starts dropping in value, right? So the value of the vehicle after T years of a purchase is computed this formula. They say, take this model, this is the model, and every year T passes 3 years, 5 years, 10 years, you plug in here, and the new value will be computed. It's gonna be less, okay? They say the vehicle is depreciated by $2,500 per year. Every year, it's dropping $2,500. Can you write this model? Can you put this number into this model and give us this formula if the drop rate is 2,500? I call it rate. And yeah, in other words, they just wanted to figure out what M and B is supposed to be if the value of the car is dropping 2,500 each year, and the initial purchase price was $25,000. No clue? What's that? So you are supposed to find these. That's your model. T will survive, T will stay, because it's number of years. So you want to find out after 20 years what's the value gonna be. You plug in 20 there. So it will be. This is up to you. But these two are fixed constants. Can you guess what M and B will be, Anthony?
The y equals 25,000 minus 2,500 t.
Okay, hold on. So it is. You said it again.
25,000.
T
No, minus
minus
2,500 t.
Okay, let me flip these two. I like variables, first numbers and last. So what you meant is minus 2,500 t. I bring this in front, this last later. 25,000, right? Okay? Same thing, right? It looks like he chose M to be minus 2,500, B to be 25 grand. And that's the right answer. Okay? So every year, this is what you started with. When you have now, if T0 means brand new car. Year 0 is in dealership. If you plug in 0, no value drop, you're at 25 grand. But 1 year later, put 1 times 2,005 negative, it drops to 22.5. 2 years later, 5 grand, 20,000. Okay? So that's the model you just created. So that's only part 1 though. Minus 2,500 T plus 25 grand. Okay, part 2. They propose a different formula because sometimes this model has a flaw. Because according to this model, what happens after 10 years? Tell me. In 10 years, your value is 0. Well, you still have car in your parking lot. How come it becomes $0, right? You can still get like $500 for it, right? 10-year car, SUV, probably still makes $4,000. So every math model actually has a flaw. So you can improve it. You can get a new model, new formula. So in part 2, they are proposing this. This is not working out great. Some cars doesn't drop that fast, slowly, and they never become $0. They propose use an exponential model. V0 is the initial money you paid for the car. B is a base, okay? And B is a base number you're gonna figure out. T is the number of years. And you need to compute this base B. V0 is already fixed, given to you, 25 grand. T is the number of years you need, whatever year you need, you put it in. But B must be found. Your job is to find B. But what's given is, every year, your car value drops to 90% of the previous year's value. Right now, if you have a car valued 10 grand, next year is gonna be $9,000. The other year is gonna be 8,100. You take another 90% of 9,000. And then you take another 90% and another 90% of every year. Can you get that B? What do you think that B will be? Any ideas? This is kind of trial error. You need to kind of guess. So initial value is V0 25,000. This is year 0. And the model you're trying to figure out is 25,000 at a rate T. Okay, what is the value gonna be after 1 year? Let's say V1. What will be the new value of the car after 1 year later? If you're losing 10% of the value, only 90%. What is 90% of 25,000? It's 22,500. Okay? So this thing becomes after 1 year, it becomes this. Right? Now can you get B? What's that? Yeah. You divide both sides by 25 grand. That's your B, which is 0.09 or 90%, 90 over 100. I was expecting you could just say it like that because it's 0.90% all the time, multiplying 25. Okay?
Wouldn't it be 0.9?
What's that?
Wouldn't it be 0.9? 0
Yeah,
minus
yeah.
9%?
Sorry, I have an extra 0. It's 0.9. But does it make sense? What's gonna be the price after 2 years? Look, to be able to compute 2 years, you need to multiply this by another 90%, or 9 over 10. For 3 years, compute this and multiply, take this and multiply by another 9 over 10. So if we can compute this all by like this, what's the benefit of having a formula? Formula is superior, why? Yeah, if you know B, I can compute after 100 years. If D is 100 years, I can compute what's gonna be the new price after 100 years later in 1 minute. Here though, to go to 100, I need to keep multiplying by 9 over 10, 9 over 10, 9 over 10, and up to 100 times. Okay? So the model we have here is 25 grand times B is 0.9 or 9 over 10 or 90 over 100 times T. Okay? And this is a better model for me because even after 100 years, if you have a running car, it will have some value with this model. It's not gonna drop to zero. So this is 25,000. 0.9 raised to the T. Okay. Now, can you compare? You have two models now. Linear model in part 1, 25 grand, losing $25,000 every year. The second one, 90% of the value model. Can you compare what's going to happen 5-year and 10-year using the linear model? First, in part 4, the last part, what's going to happen after 5 years and 10 years with the power exponential model? So first do the linear model, 5-year and 10-year. I think we can do it right on the spot here. What will be year 5 value? Just plug in 5 here, but it's 2,500 times 5. 12,500, right? Subtract from 25 grand. 5 years later, your value is, your car value is 12,500. How about year 10? We already figured this out. If I plug in 10 here, 25,000 minus 25,000 is 0 value. Okay? You have a junk car. All right, let's see what the power model says about that. All right, here is our formula. I'm wondering year 5. All I need to do is substitute 25 in T. Yeah, we definitely need a calculator though. Do you have?
$14,762.03.
60.
To 25.
Okay. And 10 years? What is the 10-year value?
8,716. 96.
96?
Yeah.
See, this model is more reasonable. After 5 years, your car value is 14,000. After 10 years, 8,000. For an SUV, they are pretty reliable numbers, right? Okay? Any questions? Alright, this is a nice application of that. What we use here, exponential function. 0.9 raised to the power t. It's a decay, exponential decay, it's going down. What is this one? It's the linear function way back in chapter 2. We had straight lines. your car value is going down in a straight line with a slope 2,500. Slope is 2,000. This is the y-intercept. Your value starts as 25 and drops gradually. Okay? Any questions? Any questions? Yes.
Will this be on the exam?
Yes. Okay. There is a new review just about exam chapters on in your homework. So we will start working on it next Monday. Okay. And so this is it. This is all you're gonna have in the exam. We don't have class on Fridays, holiday.
So, okay, so this,
Wednesday, yeah.
so is this the study guide or the one you've given us?
There is a separate one coming in.
Oh, so this part one, the next one will be part two.
This is all chapter 4 review,
Yeah.
but the next one is chapter, the sections only covered in the exam review, okay?
Oh,
And more similar questions.
forgot something.
This-
Yes, sir, I got
Your name is? For yesterday? Okay.
No, thank you.
Angela, are you still there? Yes, exam will be on Friday next week, November 18th. So I put a new exam review assignment online, so check it out. So we will start it on Monday. So can you see everything clear? Any technical issues? Any connection issues? Are you experiencing anything? Okay, good. All right. I'll see you on Monday then.